Welcome to MyProjectBazaar.com. This is our product title, Hybrid K Nearest Neighbor Classifier. This is our project abstract. The conventional K Nearest Neighbor KNN classification approaches have several limitations when dealing with some problems caused by the special datasets, such as the sparse problem, the imbalance problem, and the noise problem. In this paper, we first perform a brief survey on the recent progress of the KNN classification approaches. Then, the hybrid KNN classification approach, which takes into account the local and global information of the query sample, is designed to address the problem raised from the special dataset. In the following, the random subspace ensemble framework based on HBKNN classifier is proposed to perform classification on the dataset with noisy attributes in the high dimensional space. Finally, the non-parametric tests are proposed to be adopted. Compare the proposed method with other classification approaches over multiple datasets. The experiments on the real-world dataset from the knowledge extraction based on evolutionary learning dataset repository demonstrate that RSHBKNN works well on real datasets and outperform most of the state-of-the-art classification approach. This is our data flow diagram. First, start the program and load the dataset which is used to our system. The dataset which is as a special dataset, because we must use the special dataset for hybrid KNN. So we must load the special dataset into the database, then load the database and store into the data, load the dataset into the database, and then show what are all the things stored in the database. Then get the query vector. The query vector given from get the query vector data from the user and process the query vector to the training data set, and find the equivalent distance for training data set for error correction and extraction of the data. Then find the relative transformation which is related to the query vector and the training data set using the equivalent distance. Then find hyperland distance, which hyperland distance is the distance to find out from the query vector from the training data set. And then after finding the hyperland, we can find the fuzzy member. Fuzzy member is unrelated to our query, which is nearest neighbor of the query vector. Then fuzzy member is we can classify the fuzzy member. We can find out the predictable labels. The predictable labels which is contains the what are all the things we can relate to our query vectors to find extraction of that data from that label. Then find the k nearest neighbor data for query vector. Then after finding the query vector, you can finding the random space. Random space which is from the selected data from the of the k nearest neighbor data. So nearest neighbor data, and we can find the minimum of the attribute and the maximum of the attribute. The sum and difference of the minimum and maximum, and sum of the minimum with that getting data. Then after finding the random space, we can find the confidence factor of the selected data in the k nearest neighbor classifiers. Then after finding the confidence vector in the class of the data set, we can after class of the data set we can voting that data which is what are all the things occurrence in number of times, maximum number of occurrence in the data set and the class, and we can produce the result what are the things maximum appear in the nearest neighbor. Then the result is shown in the window. Then stop the program. Now we start the demo. First run the home page of our system. The home page is running now. The hybrid k nearest neighbor, the pictures is represented as we are running the k nearest neighbor systems. Then click the arrow button to go to the system. Now the load dataset modules are running now. We can see in the window. First select dataset. Dataset is in the dataset flow. We can see the number of datasets. Viscosin is a special dataset which is related to our system. Select that and open. Now we selected the dataset and load dataset into the database. Click the button to load. Data are loaded into the database. Okay. Then now show the data which is appeared in the screen. Yes. But the information are in the window. Then click next button to find out the equivalent distance. Equivalent distance which is related to the fuzzy relative transformation k local hyperland distance nearest neighbor classifier. It's one of the hybrid k nearest neighbor process. Find equivalent distance. It takes some time to get the result because it find out the n into n process. So we can it will take some times to sometimes to process the data. Then the equivalent distance is used in our system for expanding the data, which is removing the error sparse data. Now the equivalent distance is calculated. Then show the results. Can see that results are shown in the window. Then click next button. We appear in the screen the query vectors. We can change what are all the things we need to change. Okay, the query vector, submit the query. Now find out the relative transformation and find out the hyperland distance. After find out the relative transformation, then only we can find out the hyperland distance. Find the relative transformation, click the button. The relative transformation are calculated. Then after relative transformation is calculated, we can show the hyperland distance. The hyperland distance is now appear in the screen. Okay. Then click next button. After click next button, we can see that the fuzzy member. We find the fuzzy member which is unrelated to our system. We can avoid that related information in the database. It's selected. Then find fuzzy member. The fuzzy members are appearance in the screen. There, sample code number. Then the label. Then predict the labels, which is the nearest neighbor. Predictors are completed. Then click show predicted. The predictor are the store values. then click next button. Find out the k nearest neighbor for a random subspace ensemble framework based on the hybrid k nearest neighbor classifier. Click k nearest neighbor for the random subspace on the found. Show the nearest. Now the results are up in the screen. Then click next button. Find the random subspace for both k nearest neighbor algorithm for the fuse relative and RS hybrid k nearest neighbor nodes. Then click random subspace. The range in the RS HBKNN and the range in the fuse relative are displayed in the screen, and the default values are also displayed in the screen. Click the next button. Find the confidence vector. Confidence vector are displayed in the screen. Then check the number of occurrence. Number of occurrence with the Boolean class is in the appearance in the 7 times and the Mulligan is in the 60 times. Then Boolean is the maximum number of occurrence in the nearest neighbor. Then the result is the Boolean is the nearest neighbor class. The results are shown. Then the Boolean is the nearest neighbor classifiers, which is mostly appears in our results. Then thank you to listeners.